Hello, what's up? In this video, we're gonna continue our MAVSDK tutorials. I'm gonna walk you through your very first step on implementing your basic drone show using MAVSDK. We're gonna use MAVSDK API and peaks for offboard control to fly a drone autonomously and create some custom shapes and custom trajectories on the map. Similar technique can be used to achieve drone shows with a higher number of drones, such as commercial drone shows that you have seen in recent years. Since the goal of this video is a brief introduction to make your feet wet in drone show concepts, we're gonna use the simplest solution available, which is using MAVSDK API. Few months ago, I have created a video about MAVSDK and how to install and set it up on your computer or your companion computer. So go ahead and watch that tutorial. I'm not going to cover the details and concepts about MAVSDK in this video. The link is in the description below and should be visible on the video right now. But in only one sentence, if I want to summarize and recap MAVSDK, MAVSDK is something between your application and the MAVLink interface. It's a high-level API. It means it creates MAVLink messages and MAVLink communication for you. So you don't need to take care about sending the commands, replying to commands, and acknowledging. So you focus on your program and controlling the drone, and everything happens behind the scene. There are other APIs such as PyMavLink, DroneKit, MAVROS, and so on. Let's review some basic concepts that we might need in our tutorial. Offboard control is a relatively advanced concept that lets you control your drones from within your control loops. It lets you specifically control your attitude, rate, position, velocity, acceleration, and forces instead of just sending commands, sending location commands, or using your radio controller. So you are in a full control of your drone and can control individually every parameter and every control loop inside of your controller architecture by your commands and your codes. The set points that you might provide are, as I told you, acceleration, position, velocity, attitude, and so on. These set points should be sent to the drone using MAVLink commands. You can use the raw MAVLink commands by yourself or use a MAVLink API such as MAVSDK, ROS, or DroneKit, and so on. On the below screenshots, you can see one drone that is doing some trajectory by itself. We're gonna walk you through the tutorial that you can create these trajectories by yourself at the end of this tutorial. But let's see how it actually works, how the drone is following this trajectory. There are two ways you can use offboard control. One is sending the commands in real time to your drone using a telemetry, which is not very reliable. And another solution is to having a companion computer on your drone, such as Raspberry Pi, or Jetson Nano, or any other companion computer available. The companion computer should continuously send MAVLink commands to the PS4 and let the PS4 just run those commands. The companion computer decides at each second or each time step what acceleration, what velocity, and what position it should be at that specific time. You can send the data from ground station as well, but offboard control needs at least 2 Hz of commands being sent to it. Otherwise, the offboard control would reject and your drone would end up being in hold mode or any other fail-safe scenario that have been designed. For a complete documentation about offboard control, take a look at the PS4 documentation page. It's gonna describe every details about offboard control and every consideration that you might need to know before using offboard control. Remember, offboard control has almost no protection, so you are on your own. You have to take care of everything that your drone is doing. So you might end up losing your drone at the first second of running your offboard control. That's why you need to use software in the loop quite a while to make sure your algorithm and code works. Okay, now that we know the concepts and logics behind offboard control and the risks it has in the operation, why do we even need to use offboard control? The truth is, for most of the application, we don't even need offboard control. The Pixhawk and Pix4 controller can do everything for you and manage the risk and let your drone do the operation safely. But for some advanced applications such as drone shows, at least by the time I'm recording this video, you need to use offboard control. All the drone show applications that you see commercially on TV and in a special ceremony, just like the picture below in this slide, each of these drones quite possibly are being controlled in offboard control. It means there is a companion computer on each of these drones that is actively monitor and change the trajectory each drone should fly. Some of the drone shows are based on just predefined trajectory, at least as far as I know. Each one of them is doing a predefined trajectory and track it as precise as possible. And overall, when you see the drone show, it looks like that they are coordinated with each other. In some smart swarm controls, such as swarm search and rescue missions, the swarm need to be connected with each other. They need to share detail and they need to share information with each other and decide where to go based on their findings in the area. This is another application of offboard control. Another application might be object avoidance or following. You might want to follow a target or follow a car, or you want to create an application that avoid the train or avoid the object. In that way, you might need to use offboard control to control your trajectory in real time. Other application could be some smart AI controlled drones that can decide what to do in real time. Maybe they have an AI controlled logic, then based on what it sees and what its sensors telling it, it can decide what to do. The possibilities are endless. In this video, we're gonna focus on drone show and see how we can use offboard control for our drone show. Just for the educational purpose, we're gonna implement a single drone and make the drone to fly a trajectory, a predefined trajectory for us. Before implementing our project, let's review some limitations and considerations. As I told you, there are quite few MAVLink APIs out there. MAVSDK and MAVROS are the well-known ones for the best compatibility with Pix4. Each of them has its pros and cons. MAVSDK is a little bit easier and more intuitive to understand for beginners, while MAVROS is better for bigger projects and very complex projects. It has very good compatibility and community out there that you can use, and it's more general and more advanced. But if you're a beginner, go ahead and use MAVSDK to get a sense of offboard control and drone development to begin with. MAVSDK, by the time I'm recording this video, has a very important limitation, which it cannot feed forward the acceleration while feed forwarding the velocity and the position set point. So you have to only use velocity feed forward while sending your position set points. For the basic maneuvers, it's okay, it works just fine. But for some very advanced trajectories that needs very precise trajectory following and sudden change of direction, you might need acceleration feed forward as well. You can still use MAVSDK and create the acceleration set points manually with creating some new MAVSDK and MAVLink commands while using MAVSDK. But many users tries to use MAVROS in these projects. It depends on you and your application and your experience that you are more familiar with MAVSDK or MAVROS. In future, I'm gonna create a basic video about how to use MAVROS and how to implement it for the beginners in the next future. So until then, go ahead and use MAVSDK to get a sense of the concepts about offboard control. But basically, MAVROS is exactly the same. It does exactly what MAVSDK do. There's something in between that change the ROS messages and ROS packets to the MAVLink packets. So you don't need to take care about any conversion. Everything happens for you. But you need to understand what is happening. and I'm gonna walk you through those steps in the next videos. There are also some safety considerations for the offboard control. In this video, we're gonna use the software in the loop so there is no danger, so make sure that if you want to use this algorithm on a real drone, you have to consider some safety issues. Offboard control relies on accurate position estimation. So if your position estimation is not good, your offboard control is not recommended and you might end up crashing your drone at the first seconds of your mission. So real world offboard is nothing like software in the loop. If your algorithm works in software in the loop, don't expect that it works on the first try on the real world. So you must make sure of the GPS positioning accuracy. Try to use RTK, try to use open fields, and try to bring some extra eyes with you so they can help you while on the mission. And you should always be prepared for a fail-safe action and plan B. And don't fly in a populated area because your drone might lose control and you might need to intervene and try to hold the position and return the drone manually. So before using offboard control in real world, make sure your algorithm works no matter what. And even if you're sure it works in software in the loop, go ahead and try your drone in manual flying and make sure the PIDs are well tuned and the drone can follow the trajectory and can follow the commands. Because maybe in the software in the loop your drone looks okay, but in real world your drone cannot handle the commands you send it and it will fall behind your commands or maybe overshoot your command and end up crashing or flipping. So before engaging the offboard control, make sure your control loops, rate loop, attitude loops, position and velocity loops are all well tuned. Now that we have good understanding about peaks for offboard control and MAVSDK, let's go ahead and implement our first drone show demo. The link to this GitHub repository is already available in the YouTube description. Go ahead and make sure you have installed all the prerequisites and ready to go on. First, you need to install Python, then you need to run your Feedforewarding software development environment. There are YouTube tutorials for that from my channel. The link is available in this README section. And also for the MAVSDK installation, there is a guide and YouTube video you can follow. All the videos are available in my YouTube channels under the Peaks for Development playlist. When you're done with installing the prerequisites, the next step is to run our first offboard demo. Before using the drone show example, let's go ahead and run one of the official examples from the MAVSDK library. In that case, we make sure that our system is ready and we are ready to run our examples. I'm gonna use WSL. You can use Ubuntu or any other software development environment that's suitable for you. I'm gonna cd to the MAVSDK directory that I have installed. It's MAVSDK Python master. I'm gonna cd to that. There's a folder called example. I'm gonna cd to the examples. There are a bunch of examples here. For demonstration, I'm gonna start the Python offboard position velocity and ED. But before that, you need to run your piece for software development environment as well. You can use JMFSim, Gazebo. You can run it on Ubuntu, Windows, or any other software development environment. I have created a video about all the software development environment options a few years ago. You can refer to that video as well. I'm gonna run the software in the loop in Gazebo, and I'm gonna connect it to Ground Control as well for better situation awareness of my drone. We have the Gazebo, Ground Control, and our software in the loop in one screen. Now I can run my offboard application, offboard Python code. Before that, let's connect our Ground Control to the Feedforewarding as well. Then we're gonna run our Python code for offboard position velocity. This official example just make the drone take off to 10-meter altitude, AGL, and then go about 50 meters to the
offboard
nose,
flight mode,
and then hover there with in position mode. So the offboard control will be terminated in the air. As you can see, it is working. The drone has traveled about 50 meters north, and the offboard control will be finished here. And the drone will hold the position over that position until further commands. This
Hold flight
example
mode.
shows that offboard control and our software development environment is ready, and we can go on with our own codes. Let's make the
Return
drone
flight mode.
return and land to the home position. Meanwhile, we can go ahead and clone the repository to our home directory. I'm gonna see this the home directory. Go to the GitHub repository. You can download the zip file or just copy the Git repository URL. Return to your command line interface and simply type git clone and the URL of the repository. The repository will be downloaded, and you can see this is the directory MAV Drone Show. MAVSDK Drone Show. There are a bunch of files or folders here. I'm gonna open this folder inside my Visual Studio for better understanding. There are two folders here, functions and shapes. In the function, there is a Python file consists of many functions that creates different shapes for you. For example, heart shape, eight shapes, circle, spiral, helix, and so on. You can go ahead and create your own shapes here as well. There's also another file here called create active CSV. This Python file will be called by you, and this will actually create the CSV file needed for the offboard control. There is a structure here for the CSV, the index, time, position, velocity, acceleration, and there is documentation in this comment section below if you want to create anything based on your need. So we're gonna send the position, velocity, acceleration, and LED colors to the drone using this CSV file. You can run or create different shapes here with this CSV creator.python. Again, a description and documentation about this code is available. All you need to do is to change the name of the file, name of the shape. For example, here heart shape is selected. We can change it to circle, H shape, and so on. Or if you have created a custom shape, you can name it here. There are different options for the trajectory, such as climb rate for the initial climb, hold time, step time, start X and Y coordinate, maneuver time, the diameter, and the direction for clockwise and counterclockwise. Let's start with the square trajectory, a simple square. All you have to do is to run this Python code. If you run it, you will find a message like this. If you run the code on Ubuntu right now, you will find a plot, a 3D plot of the path that the drone is gonna take. But since I'm in WSL, the plot is not supported, so the picture of the plot is exported to the shape folder. You can refer to the shape folder and see it is working as expected. Let's change something about this trajectory. For example, let's change the starting point of the maneuver to 10 meters. So the X position means north position will be offset by 10. And as you can see, the drone first climbs, then moves to the position 10, X, 10 to the north, and then start the maneuver, return, and land. You can go ahead and play with these parameters. Let's see another shape, which is heart shape. It's a much more interesting trajectory. Again, we're gonna build the code. Go to the trajectory plot, and here it is, the trajectory of the heart shape. The main file that the code is gonna use is this active.csv. This active CSV will be read by the offboard controller. It will go ahead and read these coordinate and commands that is created by you by this Python file and send this in real time to the drone. And the last file we're gonna cover is offboard from CSV. This code actually is the main responsible for connecting to the drone, reading the commands, reading the position and velocity and acceleration and so on, and sending them to the drone. Remember, we are not sending the acceleration here. We are only sending a position and velocity right now. And we also ignore the LED coloring here as well. After the trajectory finished, the drone will return, land, and disarm. All you have to do is to run this code. You can run it from Visual Studio Code, or simply use the command line if you're more comfortable. Let's arrange my screen and run it from the command line. All I have to do is to type Python and offboard from csv.py. And then we sit back, relax, and enjoy the trajectory that the drone is taking. As you can see, it is connected to the drone. On, set the initial set point, and started the offboard.
Armed.
It's gonna
Offboard
climb
flight
to
mode.
10 meters, and it will create a heart shape for us. Just to remind you, we are not sending the acceleration feed forwards. This makes the drone sometimes deviate from the trajectory, especially if we have selected a small diameter and a very fast maneuver. It might deviate or do some abnormal transition that might be dangerous in real world. So make sure your maneuver time, speed, and diameter are suitable for your drone, and make sure your drone can handle those speed and attitudes that's being commanded to that. Okay, the first trajectory finished, the drone returned home. It's landing right now on the home position.
Land flight mode.
Let's continue with another shape. You can go ahead and search for the trajectories here or create your own trajectory with the same structure here. For example, a heart shape that we just covered, infinity shape, 8 shape, spiral square is one of my favorite, the helix, and so on. Let's go on with the 8 shape this time, the shape of an Latin 8 character.
Disarmed. Hold flight mode.
You can go ahead and change some parameter for the trajectory, but I'm gonna build the code. The CSV and the image are created. You can double check if that's okay with you. We can go on with the command offboard from CSV file. Again, the drone is ready, and we're gonna send the offboard commands. And again, we're gonna relax and enjoy the drone show.
Armed. Offboard flight mode.
Although this trajectory that the drone is traveling right now might not be very interesting, but imagine that this is the first step toward the drone show. This is the first step. Your drone is performing and following a predefined trajectory. So imagine you have 10 drones right now. Each of them will start the mission from another start point with an offset, but with synchronized time. So each drone will continue its trajectory no matter of what other drones are doing, and overall, and the viewer on the ground will see some astonishing, magnificent, beautiful view with changing RGB colors of the drone. Here I just wanted to demonstrate something for you, that what happens
Position
if
flight
you
mode.
suddenly stop your offboard command sending. In that case, it depends what failsafe you have selected. For me, it went to the position hold failsafe. So I'm gonna, as you can see, I'm gonna
Return
let the
flight mode.
drone come back and return to land manually. Make sure you have selected a good fail-safe method for your drone so you won't end up losing your drone if anything happened to your offboard control. Let's demonstrate another trajectory for the last example. Helix trajectory is a fun one, but let's do something about maybe a spiral, square spiral. Some of the maneuvers such as helix, spiral, zigzag has additional parameters such as number of the turns and bottom altitude, end altitude. In that case, you should go to the create active CSV to change those extra parameters as well.
Offboard flight mode.
In the create active CSV, you can find the specific maneuver that you are looking for. For example, the spiral square. As you can see, spiral square has another parameter called turns, which is by default set to 3. Okay, let's create another CSV file for the spiral square with 3 terms. Okay, we run the code and double check the shape and the 3D plot of the drone. It's okay, so we're gonna run this offboard control from our offboard application. Sometimes you might find this error. It means that the drone is not accepting offboard commands. In that case, your drone is already in offboard control, so you can't enable the offboard control in that time. In that case, you must change the flight mode to anything such as stabilized position.
Stabilized
and
flight
then
mode.
Send the offboard controls again. And the drone is took off
Armed.
and go on for
Offboard flight
the mission.
mode.
Okay, let's recap all we did in this video. We did the first step to our drone show, and the next step is to send the drone, send multiple drones with different start points, but with synchronized time. Then the viewer on the ground can see some astonishing great views. Right now, everything is happening in software in the loop on my computer. But in reality, each of these commands should be sent from a companion computer on board your drone. For example, you have a Raspberry Pi on the drone. At the exact same time, you're going to start the mission on each drone, and the drone will continue following the trajectory. But it's not that simple in real world. You should always have extra consideration and face-off consideration to check if the trajectory is being followed correctly. Otherwise, your drone might end up collision with each other. So this is just educational introduction video to know the concepts. There are a lot much behind it, especially with more than 10 drones. It becomes more complex and it has more challenges. I hope you enjoyed this video and it adds something to your knowledge. Thanks. If you like this kind of video, make sure to subscribe to the channel and let me know in the comment section if you have another comments and recommendation for the future videos. Until then, have a nice day and happy flying. Good day.